Isn't this great? This is Hurdles. A week, 2 weeks ago, stormy day. Wasn't very nice out, but isn't it amazing with beaches that there's no nice. Every beach is nice, and Nova Scotia's got so many really nice beaches. So yeah, anyway, thought I'd just show you. Oh, sorry, it wants to keep showing you the beach. Let's move on. There we go. So now we're into winter. This is from last weekend. Dora in I'm not sure if that's Frog Pond or not, or maybe, yeah, it must have been somewhere up around there. But she had a great time. The snow was not too deep, so her little leg, she could still jump into the soft snow and not sink under it altogether. But by Monday, after class, this is Monday afternoon, after the big rainstorm ended for the most part, it's still foggy down at the Dingle, our regular walk around there. It was bleak, but at the same time, the fog was actually quite nice. It's rather messy along here. The seagulls dump mussel shells. They fly up high with them and drop them until they break. Anyway, we've got a class to go through. So just a few updates about what's happening this week. Presuming you're seeing this tomorrow on Wednesday, that I mentioned this last class, I believe, that there is a workshop that I'm particularly interested in the bystander training that, and I think I've mentioned before, when you see things that are wrong, that people behaving in totally inappropriate ways, bullying, assaults, even, all kinds. If you ignore it and just walk away, then you're condoning it. And you're saying it's all right to do that, and it'll continue to happen. The only way we're ever going to prevent some of these things is to start changing attitudes. And that means we have to act when we see things. And acting may not be getting yourself directly involved because that might be dangerous. That I wouldn't take on a drunk that's a big person and I might get beaten up. But you have to report it somewhere. Someone else may be able to handle that sort of thing, but you can't just let it go. So anyway, if you don't participate in the training, that's one thing. I think it's more focusing on what can you do and do safely. But it's something to think about. That in terms of athletics, what's happening, that the Wednesday night, there's the women's hockey game against the All Tigers, crosstown rivals. We should show that's on campus. But I got a request from a member of the women's volleyball team that if I'm promoting athletic events, that she said nobody shows to our games, and especially when it's over at Dal. So it's over at Dalplex on Saturday afternoon, and they'd love to see some St. Mary's students out there cheering them on. And so if you have nothing to do Saturday afternoon, I think Saturday night, you've got both men's and women's hockey at St. Mary's, the arena here too. And next Tuesday next week, there's a speaker, Tarek Haddad, and he is a Syrian refugee that he and his family settled in Antigonish, somewhere up along that shore. And he started a chocolate business and has been very, very successful. He's a very good self-promoter, but I presume talking about the challenges of being an entrepreneur and being a refugee that is an entrepreneur. So it might be interesting to hear. So that's Tuesday afternoon of next week. Of announcements that are with respect to the course, a few important things. This is, they said before, this is our first big week. We have a test on Friday. And it's been set up. You should, I think, in Top Hat, see it's listed as homework and scheduled for Friday. And it will turn on at 7 a.m. And you can start at any time, but you've got to finish by midnight. Once you start, you have 60 minutes to finish. If you are a client of the Smithers Center, that you I think I've set up the appropriate accommodations for you. If you're not a client of Smithers, but are dealing with issues such as learning disability or that type of thing, you should approach them because you can get accommodations on different types of things, and it's worth pursuing. Don't fight against it. I'd have students in the past that had, in some cases, very severe disabilities, but wanted to prove that they could do it regardless of the challenges that they faced. I don't see why they needed to do that. They're not proving anything to anyone. That it's not a time test or a challenge in that regard. It's trying to evaluate how well you understand the material. Don't let other things compromise your ability to demonstrate what you can do. And as usual, on Saturday, we have quiz number 3. Every Saturday, there's a quiz. And every Wednesday, there's a discussion. On Wednesday, this Wednesday, today, if you're seeing this on Wednesday, that discussion 2 is due. And next week, you'll have discussion 3 is going to be due. I think discussion 3 is about averages. Everything we talk about, everything I see measured. I just saw a report again on average household incomes and that type of thing. But none of us lives in an average household. And averages are informative, but they don't tell the whole story. I want your thoughts on averages. Anyway, the assignment 1 I'm still working on. I hope to have it finished by now, but I'm still working on it. This is Tuesday evening. I'll have it posted by tomorrow evening. And it will be due on Friday, the 3rd of February. That it makes extensive use of Excel. Some of you may be very good at Excel. For some that are even good at it, some of what we may do is using capabilities of Excel that you're not familiar with. That software like that can be very frustrating when you can't, where did I have to click? And where do I find this, that, the other thing? And unfortunately, Excel, depending upon the version you're using, if it's for a Mac or Windows machine, and even with Windows, the Office 365 web version looks different from the one that may be installed on a computer, and the one I'm using. That if you have trouble with Excel, that you should email me about it and describe your problem and attach your whole spreadsheet. To assist you with the assignment, I'll have a tutorial. It'll be on Tuesday at 1 o'clock. It'll be through Zoom, and it'll be recorded. Very, very few students attend any of my live tutorials, but I get hundreds of views on the recorded version that students said in the past they find it very useful. I get you over the bumps, most of the bumps, in getting through the Excel part of the assignment. So it's worth taking a look. So last day we started exploring a data set. Saw it had some strange numbers, some very big numbers, some crazy small numbers. We had a sort of a look at middle values, by averages, used the total row to help us, looked at doing some filtering to see if you get different answers if you filter on different groups, looked at sorting things so we could see what all the small ones look like or all the big ones. And that's looking at it at a very granular level, looking at all 811 numbers. In practice, that's too much information. So we'd like to summarize it and collapse my data set. And one way of going ways in collapsing it is to just group things and then describe the groups you've got. And you might describe the groups with a table in a frequency distribution. Or for a lot of us, particularly that think more visually, taking that table and making it into a chart, a histogram, can be very informative. Next week, we'll do an awful lot of looking at summarizing things with numbers and tables and looking at simultaneously at charts. And very often, charts are more informative to us than the tables are. That histograms are clumsy, and we'll look at some other issues next week to do with improving that. Today, I want to look at, suppose you want to summarize it even more and reduce it down to single numbers that describe the middle, to describe low, to describe high, and a difficult concept to describe diversity. How spread out is your data? How would you measure that? So with histograms, they focused on giving you important landmarks of where's the middle, where's low, where's high. It helped us identify outliers to some extent, extreme values, that we had to scale things so we could make comparisons, look at relative frequency when you've got two groups you're comparing, and for one group you've got 300 observations, and the other group we have only 100. Then frequencies, of course, the big group has got 3 times as many values as the small group. How do you compare them? Make them on the same scale then. Treat it like both groups are 100, so make them into percentages. So there the total would be 100% for group A and 100% for group B. And then you can compare things. So scale is important. And we'll see that as we move forward in different things. But suppose we want something much simpler. And you can think of that. You're going to do a test Friday. That if you were in a classroom, and if it was a pencil and paper test, we'd be passing them back on Monday. And you'd be looking at your grade. I got a 76. Hey, it's a B plus. Pretty good. Happy with that. But how did everyone else do? Is my grade really a good grade or just an average grade? Maybe it's even a low grade. That you need a benchmark, some standard to compare it to. So you'd think first, well, what was the class average? And if the class average was 58, you would say, oh, I did well. But if the class average was 82, it was that easy a test and I only got 76. So the average gives you a sense of, are you above or below? But you aren't even sure, are you far above or far below? First, let's get a sense of where's the middle. Then we can think about what's high, what's low. In defining the middle, we think of the class average, but there are many different measures of the middle. And the most common ones are what statisticians call the mean, which is what most of us call an average, and the median, which is a different sort of middle. Some people might call an average of a sort as well. So these statisticians are the ones that talk of mean values. The general public talks of average. In Excel, we found it in the total row, and they called it average. It's just take all the numbers you've got. So there were 752 salary values. Add them all up. Divide through by 752, the number of values you've got. And you get that average. In terms of notation, that we usually use a small x with a line over the top, a bar over the top. So they call it x bar. And this is the average of your sample, the sample mean. That as a formula, it's the sum of all the observations divided by the number of observations. In symbols, that if x represents salary, then the sum of the salaries is usually written with this funny squiggle here, like an E almost. It's the Greek letter sigma. It's a capital S, and capital S to represent the sum of whatever follows. And the number of observations, we typically will use a small n to represent the number of values in our sample. So that was our 752. In calculating this, every value, every observation is equally important. The crazy numbers are just as important as the ones we think are quite realistic. And we include the crazy numbers. All the values are included, which may cause problems. So as I said, this was the average in the total row in Excel. That in this case, the average salary was almost $53,000. There are other types of means, other types of averages that we won't look at those, but some people might look at what they call a trimmed mean, where they trim off the bottom and trim off the top. We'll actually do that in a minute, that just to get rid of the crazy values in case there's some crazy ones. Shouldn't affect the mean much by just snipping the two ends off. Some people like to calculate a weighted mean, and weighting meaning that some observations we think are more important than other observations. And we're not going to get into that, but weighting is actually a common practice for certain types of things beyond the scope of our class. Whoops, let me go a little further here. So what's a median? I mentioned that one before. Well, in part, it's there to get rid of the extreme values. Like we had some that were crazy high values for salary. We also had crazy low ones, people that gave us 0. We know that doesn't make sense. We should throw it out. But we don't necessarily know which ones are really crazy and which ones are just high or low, but they're real data that maybe, that the person that said 650,000 is a prince or a princess that comes from an incredibly wealthy family and expects to earn $650,000 a year. Who knows? That so it's not in that regard. We may think of it as an outlier. It is strange. Instead of trimming those off, leave them in, but calculate the middle in a different fashion. That calculate the middle in the sense of, if you were looking at where's the middle of your street, where's the middle of the road, you're not averaging things out. You're trying to get half to the left of you and half to the right of you if you were in the middle of the road. So let's get in the middle of our data. Let's find a value so that half of our data is smaller than the median and half is larger than the median. And that if you sorted your data from smallest to largest, then go down that list and pick out the number that's right in the center of it all. That's the middle. And that middle isn't affected by what is at the extremes, because it only depends on what are the values right in the middle. So median is often popular when your data is highly skewed with income data. That if you worked out what's the average income of Nova Scotians, you'll get one figure. But we do have some people in Nova Scotia that have crazy high incomes. They make obscene amounts of money, and they'll pull that average up, just like that 650,000, pull the average up. And they don't really represent typical individuals. So if you find the median, then it's one where half of Nova Scotians earn more than me and half earn less than me. And so that sense, I'm in the middle. And so median is very attractive when your data is skewed, because it doesn't get pulled by those extreme values in that direction of the tail. Oops. So with the salary data, we sort of looked at it, I think, and I showed you what it looked like sorted, and what small numbers look like. And I scrolled through and I just looking at them down through the middle of them, and we found a whole bunch that were around 50,000 that seemed to be around the middle. Well, if you take, we had 752 values. So half of that is 376. So where's a number that 376 are smaller, 376 are bigger? So I could just go and count down after I've sorted. Now remember that we have a label up at the top that says salary. That's in row 1. So our net data actually starts in row 2. So I should actually go down to row 377. And that turns out to be 50,000. Or I could have started at the very bottom at row 752 and I count up 376 values, that'll take me to the row 378, and it's also 50,000. If the numbers were different, I would average the two and say that the median is in between the two values there. So it's easy to find. I don't even need a calculator on this. So which one should you use? There are a lot of nice things to be said about the median. As I said, outliers, skewed data, those types of things are not an issue. It really is the middle, just like we think of being in the middle of the road or the middle of a room or the middle of whatever. We're saying half the space is to the left, or half the distance to the left, half to the right. That's what the median is. Half my data is above, half is below. That being said, I think we've been conditioned over time in hearing what averages are, that in sports, you think of all kinds of performance measures of athletes are all in terms of what their average is. Average this, average that. When we think of grades, we look at averages. We calculate your grade point average. Everybody thinks of averages as representing the middle. So you're fighting against established practice to be wanting to go and use the median. We still do use it. We do use it with a lot of economic data. But anyway, let's move on. What about high and low? That if you were told, you got a 76, okay, did many people do better than me? And said, oh, someone got 100 on the test. Ugh. But is that just one person? Are there others? Is there a gap between my 76 and that superstar that got 100? On the bottom end, suppose you did poorly, you only got a 52. Well, how bad could I have done? And you're told, well, someone got 0. They just left all the questions blank. Unfortunately, it happens. Yeah, but that's not, both of those cases, the 0 and the 100, are not normal cases. Those are extreme cases. And that's not what I'm talking about. I mean, did many people do better than me? Did many people do worse than me? How did I rank, in a sense? So with incomes, when we talk about very high incomes, often the media would talk about the top 1%. Who are those people that only 1% of the population earns that much or more, and 99% of the people earn less than that amount? Or maybe, okay, 1% may be extreme. How about the top 10% of income earners? How much do you have to earn to be in the top 10%? That similarly at the bottom end, low income, what does that mean? Is it an income that, only 10% of the population earn that little amount or less? Would probably cut low income at maybe 20%. 20% of the population earn less than that. How do we define these things? That generally, these are defined in terms of a thing that we call percentiles. So that finding them, we sort the data, say smallest to largest. If I'm in the top 1%, I might 1% of 752 is 7.5, or about 8. So let's count 8 places from the top. That's $175,000. Top 10%, that's 75 people. Let's count down 75 people in my list from the top, and I get $80,000. So maybe high income would be 80,000. If you want super high, it's 175,000. And we could do the same at the bottom end, same way. In giving it this name percentile, should we count from the bottom or count from the top? Well, percentiles are actually measured from the bottom. The 90th percentile means 90% of people would earn less. Only 10% earn more. So the 90th percentile is way up high. The 10th percentile is way down low. So remember your relative perspective when you say that. So maybe we should define low income as being in the 20th percentile, or high income as being in the 90th percentile or above. But who defines that? Who decides what's low, what's high? It's arbitrary. It's your choice. You're going to have to define it. But percentiles are a nice way of defining it. Should mention the 50th percentile. That's half or below. So half must be above. That's the median. So the median is also known as the 50th percentile. That's dividing things up into portions of 100 percentiles, into percentages. Suppose we do our division differently. The median splits things in half. Suppose I cut it up like cutting a pie or cutting a pizza. Okay, I'll slice across the middle to cut it into two halves, and then I'll take the two halves and I'll slice them in half, and I'll split things into quarters. I could split further. But quartiles are very popular. Those are numbers that split my data into 4 groups, each representing 25% of my values. I have a first quartile that's the bottom 25%, then the second quartile, third quartile, and then a fourth quartile, which is the top 25%. That the second quartile, so that's after the second 25%, that means 50% of the values are less. That's the median again. Second quartile is the median. That and remember, we only have 3 quartiles. We've got 4 groups, but we only need to make 3 cuts to split it into 4. Why would you do this? Who cares? Well, sometimes when studying our data, that it's nice to take numeric information and split it into categories to compare categories. So if I took students, those students that are working, so I may do a study to see those that don't work at all because they've got parents or scholarships or something with enough money that they don't need to work to be able to pay for school. And then all the other students that have to work to be able to pay for school. And you may want to compare those 2 groups and see, what do their grades look like? What's their mental health look like? Those types of things. If you're exploring finances and performance or success measures. That's what we talked about at the very beginning, trying to study some of our data. But you might also go and look at, say, those that are working. They don't all work the same amount. We have some students that they work a few hours, 1 shift maybe, or 2 half shifts or something per week. And others that are essentially working full-time. Some of them are working actually far more than full-time. Talking to 2 the other day that are both working 3 jobs a week to be able to pay for school. What's the difference between those? And so maybe I'd like to look at the bottom 25% of students versus the top 25% in terms of hours worked. So how many hours a week would you have to work to be in the bottom 25%? Probably under 8 hours. And to be in the top 25%, probably more than 25 or 30 hours. And how do they compare with respect to their grades, mental health things, other types of issues? So quartiles are sometimes nice in splitting things up to describe the bottom group and the top group. But you can define them all kinds of different ways. So this suggests that not everybody's the same. There's a lot of diversity. We have a lot of diversity in our students. And in the general population, there's everybody's different. How different are they from one another? And you may think, oh, just everybody's all different. It's not the case. Take a country like Finland. Finland is often rated as one of the happiest countries in the world in terms of the World Happiness Index type of thing. They also have among the lowest income disparity. The gap between the rich and the poor is very, very small in Finland. Interesting place to look at. Whereas a place like the US, there are huge gaps between rich and poor. Canada is a little bit better, but still a lot of gaps between rich and poor. So how do we measure income disparity in a place like Finland versus income disparity in a place like Canada? And so how do you measure variability or diversity? Finance people measure diversity in investments, volatility, a stock that bounces up from day to day, goes all over the place, versus stock that it barely changes from one day to the next. So how much volatility is there? Again, that's diversity. So there are different ways. I could look at the difference between the minimum and the maximum, but those are both crazy values. Those are, what's the highest you've ever seen? What's the lowest you've ever seen? And you may get those extremes, but most days you don't see those extremes. You see it bouncing around in the middle. So what do those look like? What sort of average variability? And so looking at the range isn't a good measure. So if I'm looking at variability, sort of like I was asking before about test scores, are you above average, below average? So the average salary students expected in that survey was about $53,000. So someone that expected to earn 20,000, that's low. How low is it? Well, it's about $33,000 below average. Oh, that's quite a bit. How about 65? Hey, that sounds pretty good. That sounds well above average, doesn't it? Well, no, it's only 12,000 above average. Oh, so looking at how much above average or how much below average you are, maybe that's a way of measuring things, diversity. So typically, how much above average or below average are you? On average. See, an old measure that we measured that with, particularly when we had to do things manually, was the mean absolute deviation. So take the average, look at all the values, calculate the gaps between the values and the average, and average those gaps out. So if it was a negative difference, like you were below average, just ignore the minus sign. Okay. So we're just looking at the size of the gap, not is it a positive or negative gap. Mean absolute deviation, it's simple. I can understand what it means. I know where it comes from. But nobody uses it. The only ones that still use it are people in forecasting. And we would talk of a forecast that was on average, our sales are 200 units above or below average, or above or below forecast. And we'd look at the average error in our forecast. But beyond that, it's rare that I see it being used. And it's in part because if you get into theory and a lot of sophisticated modeling, you'll probably end up wanting to use calculus. Calculus doesn't work with absolute values, it runs into serious problems. Calculus likes nice curves. And one way of getting rid of a minus sign is to square the number. So you could take 32,000 minus 32,000, square it. And what do you get? Something like, I think it's 128, or I can't remember. Anyway, you square that number and the minus sign disappears. So what mathematicians propose doing is take those differences, square them, and average out the squares. Even that they didn't do in a way that may make sense to you, because they didn't do that for 752 values. So divide through by 752, they divide by 751. They're just messing with your brain. It doesn't make a big difference one way or the other. The big challenge is I end up with square dollars. So if I take, it was like 12,000, square it, I get 144,000 square dollars. What's a square dollar? Because I looked at the difference of $12,000 and I'm squaring it. So that becomes 144,000. But Oh no, that's sorry, 144 million. But my units also get squared, so my dollars become square dollars. What's a square dollar? This thing is known as being the variance. And when I add it all up for this data set, it ends up being 1,940,000,000 square dollars. That doesn't make sense. Well, I can fix the units. I can get those square dollars back to dollars. I'll just take a square root. So I get $44,000. This looks very complicated. There's a formula for it called standard deviation when we take the square root, usually written with a small s. And it looks like a formula that could be very tedious to calculate if I got a lot of numbers to work with, and it is. But this is far and away the most commonly used measure of variability, diversity, is the standard deviation. Understanding what it means, I don't know, I look at this formula and it's totally confusing. It's just a number. Okay. But interpreting it, there turns out you can interpret it in some situations. And it's if the pattern of our data is bell-shaped, well, the salaries are sort of bell-shaped. They got a tail, long tail to the one side. And I can't have a lot of outliers. Well, my data has a lot of outliers, so it is problematic. This rule is not going to work very well, but let's start looking at it anyway. And then we'll look at it with the outliers taken out, okay? So if I look at it, the empirical rule, so I'm looking, it works if I got a bell shape without outliers, okay? Then if you take your mean and step out one standard deviation each way, so I'm at 53,000, standard deviation's 44, so if I go down to 9,000, or I go up to 96,000, 97,000, something like that, I should include about 2/3 of my data. Technically, it's 68%. In this case, it's going to actually include more than that because my data is very screwy. But normally, if I go at one standard deviation each way, I should get about 2/3 of my data. So typical values. And if I go out two standard deviations, I'll get 95%, almost everybody. So typical values are within one standard deviation, and it's unusual to get values more than two standard deviations away. And it's rare to get observations that are more than three standard deviations away. Unless you've got a really big sample, you'll get a few, but not many. So with this data, as I said, it gives you screwy numbers from $9,000 to $97,000. And if I went out two standard deviations, I'd be going down to minus 30 some thousand up to plus some huge number. Those don't make sense. So you get crazy results if you've got crazy outliers like we do. So let's trim things off. Let's look at only the values between 10,000 and 120. Those are more reasonable numbers. 10 is still really low, 120 is still really big, but they aren't totally crazy numbers. And if you just look at those, the mean is 50 and the standard deviation is 20. And so if I go out 20 on each side, I'm saying about 2/3 of my data is between 30 and 70,000. That's typical answers to the survey was between 30 and 70. And if you look at the data, that's right. About 2/3 of people said between 30 and 70. And most of your data should be between 10 and 90. And if you go and look at your data, yeah, almost everybody's between 10 and 90. There are a few extremes beyond that. So that actually works really well. And in practice, that's what happens. If we throw out the outliers, calculate our standard deviation and our mean, then this rule is really good. Why do you use it? Well, if I wanted to picture what does all my data look like without it looking at all the data, and they tell me mean is 50, standard deviation's 20. I could think, oh, so a very low value would be $10,000. I shouldn't have many, if any, people below $10,000. I will have some low values that are around $30,000. Typical value is around 50 in the middle. My high values tend to be up around 70, and the really high ones are above 90. So I can describe very low, low, middle, high, very high, quickly, easily, just knowing two numbers. That's why standard deviation can be useful. But as a number itself, I can't see it, but I can see how I can use it. In practice, we don't do these things by hand. Should never do any of these things manually. In Excel, we've got a way of getting a lot of these typical quick summary measures, and they're known as being descriptive statistics. So in Excel, go and click on data analysis, we did last class. From that list of different tools that are there, pick the one that says descriptive statistics. Okay? From there, it asks you to tell them a bunch of things. One, where is the data that you want? So I'm in my salary column, and I think that was column M. Is that right? There it is. You can see it over here on the right of my screen, column M. And I'm going from row 1 to row 812. Row 1 is the label that says salary. So I've got to check off that labels are in the first row. My data set has all of the variables in columns. So I have to click off that they're grouped by columns. With my output, I typically put my output into a new worksheet, and it's just cleaner. I don't want too much clutter. Down at the bottom, it has different checkboxes of things you can check off. Generally, the only thing we check off is summary statistics. We're not going to bother with the other ones. Okay, so I've got that stuff. Click that, click OK, and I get a table. And the table lists a whole bunch of different things. Some of them we've already seen, some we haven't. So there was the mean value. That was the 52,914. Good. Then there was median. That was 50,000. Yeah, we found that before. That makes sense. Mentions the mode. The mode, if you're looking at the histogram, it's where's the peak. It's supposed to represent the most frequently occurring value. And in our data set, we had a lot of people that said 50,000. But if this data was actually not asking what they expected to earn, but was actually data taken from tax returns 2 years after graduation, then each person would have had a different number on their tax return. You know, maybe it's 50,000 is really $50,312.18. Or maybe it was $49,852.37. All kinds of little slight differences that we'd say, oh, that's around 50,000. And there wouldn't be many values that would occur exactly twice or 3 times or 4 times or 50 times, because everybody's just a little bit different. The mode wouldn't make an awful lot of sense here. It is in a picture as being where the peak is, but mode is not a value I'd typically pay any attention to. Standard deviation, we calculated that before at 44,000. Sample variance, we looked at that before. That was the 1,900,000,000 and some million. It's written here as 1.9, and then I've got an E plus 0.9. That means take that decimal place and move it 9 places to the right. It really represents 1.94 billion. A billion has 9 digits to it. Or a billion is a number with 9 digits after it, should I say. So this is scientific notation. It's little unnerving. If you widened your columns, so if you made column B much wider, you'd see the whole number. It's a great big thing. Let me skip kurtosis and skewness for a minute. Skip over range. We've got minimum is 0, maximum was 650,000. So those were my two extreme values. Yeah, big deal. I rarely do I care about the absolute extremes, because they may be just one value that's extremely small or one value that's extremely large. The range is the difference between the two. I generally don't use that because it's talking about extremes. The sum, that's adding up all the numbers together. I really don't care about that either. 752, yeah, I'm interested in that. I'd like to know how much data did I have. Let me look back to these things I skipped over. What is skewness? Skewness is you've got a distribution that goes up and then may have a long tail on the right or a long tail on the left. Does it look like a bell that you've gone and hit it on one side and pushed it in one direction with left a tail in the other, or pushed it the other way with a tail to the left? Skewness is a measure of how unbalanced that curve is. Do I need a number to describe that? I wouldn't use it. A picture is much more useful in trying to get a sense of the pattern. Kurtosis, sometimes we get it's not quite a bell, it's like it's a fat, skinny column in the middle, and the tails don't just go zoom down and long at 0. They go down, but they're fat. They're sort of thick, like a rat, off to the left and to the right. Kurtosis is a measure of, is it more sort of domed with skinny tails, or is it squished in the middle with fat tails? Okay, picture is better at telling you that. I don't know how to interpret 97 is kurtosis and 8.4 is skewness. Pictures tell the story a lot better. So that leaves me one thing I haven't mentioned, that's standard error. And that one is really, really important. We're going to see it pop up all the way through for the next couple of weeks. And it's quite important to us. So what is it? I did a survey and I had 752 people tell me their salary. If I could go out and do that thing all over again and got another 752 answers, some of them or all of them are going to be different. My average overall is not going to be 53,000. Maybe it's 54,000. Maybe it's 50,000. I don't know. It's different. That we're going to be using an average from a sample, and generally that's what we do with when we're studying data, is we're trying to take what we have in the sample and generalize it to the broader population that we got the data from. So data in your survey, I'm trying to speak back to students in general. What would they be saying to different questions? And so what I've got in my survey is just an estimate of that larger group. Is it a good estimate? Is it close? Like what would be close? My estimate is $53,000, but could it be 50,000? Could it be 45? Could it be 40? Could I be that far off? Can you tell me how accurate the figure is? I can. I can do that with standard error. And I do it by using a trick that's much like the empirical rule. My estimate is typically within one standard error of the right answer. So 68% of the time, the error in my estimate is only $1,600 approximately. And it's relatively uncommon. 95% of the time, my estimate is within 3,200, two standard errors of the correct answer. So saying my estimate of 53,000, is it accurate? I might say, well, most of the time it's within about $1,600. And it's rare that I'm off by more than 3,200. I could be, but it doesn't happen very often. And it's very rare for me to be off by 3 standard errors, to be off by 4,800, about $5,000. That so if I was asked, okay, should I trust the data that I've told you that I think students expect to earn $53,000 on average, and you know that yeah, sample data questionable. 53, I don't believe you. I would say that, well, I'm quite confident that it's between about 50,000 and 56, about within about $3,000 of the right figure. And 95% of the time, my estimates within about $3,000 of the correct figure. And this time, I think that's the case as well, that the correct measure should be between 50 and 56,000. I'm not sure if you can wrap your head around that. This is studied in a more formal fashion, in a more precise fashion in your statistics course, Management Science 2207. But that's basic concept that's there, is that. So where are we? I'd like to be able to summarize my data in as simple, compact a fashion as possible. And that's by saying, where's the middle, where's low, where's high? And that maybe even saying further, is my data very diverse or are most values quite similar? So for middle, I like using the mean or the median. For high and low, I could use percentiles and talk of the 10th percentile and the 90th percentile, that type of thing. Or if I got the standard deviation, I could talk of high and low in terms of 1 or 2 standard deviations from the mean. And that might be a way of conveying that information. And if someone was to challenge me on your middle, that's where we're focusing so much of our attention, how accurate is it? I can, again, go back and use that same rule of thumb and say, I'm likely within 1 standard error, and it's very unlikely I am more than 2 standard errors away from the correct answer. That's quite a lot. You're able to say with just a couple of numbers. And it's surprising we can actually pull that and say, make those sorts of statements with a fair bit of confidence that they're, and be right most of the time. So that's where we are at the moment. Now, next class, we're going to get to look at relationships, which is when it gets interesting. Instead of talking about one variable, like do students work a lot or not work a lot, that to say who does. Maybe I'm comparing 2 groups, Canadian students versus international students. Who works more hours? Is there a pattern there? That students that work many hours, do they have more incidents of depression or stress? Do they worry more about their grades or worry less about their grades? Those that worry about their grades, does that lead them to do better in their courses or worse in their courses? Is there a relationship between 2 variables? And we'll generally be looking at categorical variables, at least one. When we're looking at a relationship between 2 variables, we're generally going to be looking at one of them being categorical and maybe the other one is as well. And the week after, look at cases where we've got focusing a little bit more on numeric variables. So we're going to move in terms of increasing complexity of how we're looking at our data. But that's for another class. So that's it for now. Thank you very much. And I'm going to stop recording this time.